Hi everyone, in this video I am going to solve some of the previous IES problems. The problem number 1, copper has a resistivity of 17 into 10 power minus 9 ohm meter. What is the end to end resistance of a copper strip 2 cm long with cross sectional area 5 mm into 1 mm? First of all, what are the data given in the problem? First one is resistivity is given, length of the conductor is given, area of the cross section of the conductor also given. First of all, I am going to write the data given. So rho equal to 17 into 10 power minus 9 ohm meter. Second L is given 2 into 10 power minus 2 meter. A is equal to 1 millimeter into 5 millimeter, that is 5 into 10 power minus 3 into 1 into 10 power minus 3. So 5 into 10 power minus 6, all are converted into meter. So what is the equation to find out the resistance? R equal to rho into L by A. Now have to substitute the values here. 17 into 10 power minus 9, L is 2 into 10 power minus 2 divided by 5 into 10 power minus 6. That is equal to 17 into 2 divided by 5 into 10 power minus 11 plus 6. Here have to cut this 3.2 3.4, that is equal to 6.8 into 10 power minus 5. Now I have to multiply 10 with numerator and denominator. So 6.68 into 10 power minus 6 or 68 micro ohm. Next I am going to explain the problem number 2. A 12 volt automobile light is rated as 30 watt. The total charge that flows through the filament in 1 minute. The question asked is total charge. Total charge is Q. And power is given. Voltage also given. So what is the equation? Q is equal to current flowing in 1 second. So what is the relation between I and P? P is equal to V into I. So from this I is equal to P divided by V. So in this equation I am going to substitute P by V into T. So what is the value P? That is 30. And what is the value? Voltage 12. Time is in minutes. I'll get the answer 150 coulomb. So this is the answer for Q. Next problem 3. If the length of a wire of resistance R is uniformly stretched to n times its original value, its new resistance is, that is the question. So the old resistance is R and we are going to find out the new resistance. See a conductor with the resistance R, it is stretched to n times. So what is the value of resistance R2? That is the question. So here first consider the resistance R and R2. What about the volume of both the cases? Volume in both the cases remains same. So V1 equal to V2. Here, what is V1? V1 is A1 into L1. V2 is A2 into L2. Here, the length is stretched n times the original length. So L2 equal to n into L1. In this equation 1, I am going to apply L2. So A1 into L1, that is equal to A2 into n into L1. Both L1 get cancelled. I get the relation between A1 and A2. So now what is A2? A2 equal to A1 by n. Now I am going to find out the new resistance. So new resistance R2 equal to rho into L2 by A2. So what is L2? N into L1. And what is A2? A1 divided by n. Now I get n square into rho into L1 by A1. So what is rho into L1 by A1? That is the whole resistance R. Now what is R2? R2 equal to n square into the whole resistance. So this is the answer for this problem. Next problem number 4. The drawn wire of resistance of 5 ohm is further drawn so that its diameter becomes 1/5 of the original. What is the resistance with volume remaining same? The condition given is volume remaining same. So V1 equal to V2. How to get volume? A1 into L1, that is equal to A2 into L2. Here diameter is given, so area I have to write in terms of diameter. So 5/4 into D1 square into L1, that is equal to pi/4 into D2 square into L2. Here the diameter becomes 1/5 of the original, that is given. So pi/4 into D1 by 5 the whole square into L2. Now pi/4 into D1 square into L1 equal to pi/4 into D1 square by 25 into L2. Both the pi/4 get cancelled. D1 square get cancelled. So now we get the answer L2 equal to 25 L1. So L2 equal to 25 L1. D2 equal to D1 by 25. Both the values are known. I am going to find out the new resistance value R2. Rho into L2 by A2. So what is rho into L2 by pi/4 into D2 square. Next, rho into 25 L1 instead of L2 divided by pi/4 into D1 square divided by 25 square. So 5 square, that is 20. 5 square, that is 25. D1 by 5 only. Now I have to rewrite this rho into L1 pi by 4 into D1 square into 25 into 25, that is 625. So what is this value? That is the original value of resistance R. The value is given, that is 5. So 5 into 625. So what is the new resistance R2? 3125 ohm. That is the new resistance R2. That's all. Next problem number 5. 3 parallel branches of resistors are connected across a DC source as shown in figure. What is I1 is to I2 is to I3? Here the question is to find the ratio between the currents I1, I2 and I3. First of all, I have to draw the circuit. Here 3 resistive branches. It is connected across the voltage source E. Here R1, here R, 2R and 3R. R, 2R, 2R, 4R and 6R. The currents flowing is I1, I2 and I3. Question is to find the ratio between I1, I2 and I3. So from this, how we can write I1? From Ohm's law, I is equal to V by R. So E divided by 2R is to E divided by 4R. What is I3? E divided by 6R. Next, common terms R get cancelled. Next, I am going to take the LCM for 2, 4 and 6. So 1, 2, 3. LCM is 12. Now 1 by 2, 1 by 4, 1 by 6 is the ratio. Now multiply each with 12. 12 and 12. So what is the answer? First 6, here 3 and here 2. So the ratio between the currents are 6 is to 3 is to 2. That's all. Next problem number 6. For the circuit shown in figure, find R equivalent. Here 3 resistances given, 12 ohm, 12 ohm and 12 ohm. Here this is the wire that connect the 12 ohm and 12 ohm resistance. Another wire connect these second and third 12 ohm resistance. First of all, I have to give the number. The one is connected to here 1 and the second point, one wire is connected to another one, the same second point. Okay, what I have to do? I have to redraw the circuit diagram. I have to mark the point 1. Here I have to mark the point 2. So between 1 and 2, the first 12 ohm resistor. Between 1 and 2, the second 12 ohm resistor. And between the third 12 ohm, that is connected between 1 and 2. So all the resistances are same. 12 ohm, 12 ohm. Here I have to put the value R equivalent. See, the three resistances are connected in parallel combination. So what is the equivalent resistance? R equivalent is 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. That is equal to 1 divided by 1 by 12 plus 1 by 12 plus 1 by 12. So that is R equivalent. So 1 divided by 3 by 12. So 1 by 4, that is equal to 4 ohm. So this is the value of R equivalent. Next problem, problem number 7. 12 1 ohm resistances are used as edges to form a cube. The resistances between two diagonally opposite corners of the cube. Here, find the resistance between two diagonally opposite corners of the cube. So first of all, what I have to do, I am going to draw the cube. So see, this is the diagram of cube. Here this is the diagonally opposite sides of the cube. First of all, these opposite sides I am have to connect the voltage source. So when current is flowing here, all the resistance are equal and that is 1 ohm. Okay, now this current can be divided into 3 equal parts, I by 3. And here I by 3, here also I by 3. And this I by 3 again divided into 2 equal parts, I by 6 and I by 6. And again this I by 3 that can be divided into I by 6 and here I by 6. And next see, this I by 3 again into 2 equal parts, I by 6 and this one is I by 6. So this I by 6 and I by 6 together, that is again I by 3. Here this I by 6 and I by 6 together, so that is again I by 3. And this I by 6 and this I by 6 together, again I by 3. So finally the same current, incoming current or outgoing current from the source is same. Now our assumption is correct. Okay, next I am going to find out the resistance in the opposite corners of the cube. So this is the opposite corners. So here I am going to find out the resistance. Consider this as a closed loop. Have to apply the Kirchhoff's voltage law. So or KVL. So now here this is the voltage rise E. And here see here I by 3 and the resistance 1 ohm. So 1 into I by 3, that is I by 3. And see, this is minus I by 6. Here minus I by 3. So that is equal to what? 0. Now E minus, what is the LCM? That is R, 6. Here 2I minus I, again minus 2I equal to 0. So what is E? E equal to 5I by 6. So from this, what is E by I? That is equal to the resistance R 5 by 6 ohm. So this is the answer for the resistance in the opposite corners of the cube. So next problem 8. N resistors each of resistance are when connected in series offer an equivalent resistance 50 ohm. In parallel equivalent resistance 2 ohm. What is the value of R? For example, you have to consider when two resistors are connected in series. If both are same, what is the equivalent resistance to R? Suppose N resistors are connected in series. So what about the equivalent resistance NR? So the NR is given what? NR equal to 50. And when two resistances are connected in parallel, so 1 divided by 1 by R1 plus 1 by R2 equal to what? 1 divided by, both are equal. So 1 by R plus 1 by R, that is 2 by R. That is equal to R by 2. Therefore, if n numbers of resistors are connected in parallel, the effective resistances are R by N. So that is equal to, the value given is 2. So what is the next step? Multiply this effective resistance. Now 1 and 2. So 1 into 2, that gives R by N into NR equal to 50 into 2, that is R square equal to 100. So what about the resistance R? R is plus or minus 10 ohm. But you have to take R as plus 10 ohm. Okay, this is the answer. The problem given is the current 2 ampere passes through the cell of EMF 1.5 volt having internal resistance of 0.15 ohm. The potential difference across the terminal of the cell. Here see, the cell is connected. So internal resistance also connected in series with the cell. So V here E, and this is the resistance. The current flow is 2 ampere. Okay, here I have to write the equation using KVL. What is the value? V minus E plus I into R equal to 0. So V is equal to E minus IR. So V is equal to E is 1.5 minus 2 into I is 2, R is 0.15. 1.5 minus 0.3. 1.2 volt. This is the answer for voltage across the terminal of the cell. Next problem number 10. In a given figure, find the value of resistance. Here in the circuit, one of the branch current is given 2 ampere. And question is to find the resistance R. Here one of the best method used to find out the resistance R is nodal method. I have to mark the nodal voltage here, that is V. And also I have marked the currents. All the currents are flowing away from the junction. Next, Here I have to mark the reference node. Reference node has 0 potential. Next I am going to write the equation using KCL, Kirchhoff's current law. So see here, first V, negative to positive, so this current opposes this one. So how to write? V minus 100 divided by 10 plus V minus 0 reference value divided by 10. Here assume direction, actual direction both are same. So this also plus 2, that is equal to 0. Next V by 10 plus V by 10, and you have to separate the constants. Minus 2, 100 by 10, that is minus 10. So if it is go in the next side means that is plus 10. So what is the net value? 2V by 10, that is equal to 8. So you have to multiply this 4. So V is equal to 40. But from Ohm's law, R is equal to V by I. We are going to find out the unknown resistance. Now we know the voltage for this branch. So the voltage is 40 and the current is 2. So the value is 20 ohm. This is the answer for unknown resistance. Thanks for watching. Have a nice day.